in half, but not all the way, like this. You put your grape in the microwave and put the glass on top of it. Then we're gonna grab our can and put it over the fire and heat it up a little bit. Inside of the can a little bit of water. Let's see what happens. You just need eye protection, film can, and the Alka-Seltzer. And we're gonna make a rocket. Put some water up in there, then open these tablets, drop it in, close it, close the cup, put it down here, see what happens. Holy crap! So you see this arrow pointing left, and then what if I'm gonna put glass to it? Still left. And then I'm just gonna pour water, and guess what's gonna happen? It's gonna point right. If you don't believe me, left, right. Put your milk in. Then put your food coloring in. I got green, I got red right here, or orange, whatever it is, and then I got red right here, and then I have blue. Then just get your dish soap and drop a couple drops in there. Check this out, isn't it awesome? And then you're gonna get a pin and just like make bunch of holes. And you see water stop coming out. 1, 2, 6 holes. And then you can leave it on a table and wait, or give it to somebody and they press on it and it just spills. You see it? Close up. We're gonna put a little bit of water. You see how water is boiling out because it's too hot? So it's been about 2 minutes. You see how hot it is? And let's put just a little bit of water. Just a little drops. You see how all these drops just like spinning around and not boiling out? I want you to comment and tell me why. Let's drop some more.
A friend who's in liquor production has a still of astounding construction. The alcohol boils through magnetic coils. He says that it's proof by induction. Human beings are, for better or worse, stuck in a subjective experience of the world that can vary in important ways from person to person. We all generally agree that there's something out there that we can all touch and experience in our own unique ways. But how much of that experience is us, and how much of it is actually out there? That's harder. Accessing truth is something that we all do, or think that we do, all the time, using all sorts of different methods that we can choose to trust more or less than the others. There's philosophical rationalism, where the truth is revealed if you reason hard enough. There's religious faith, where the truth is revealed through revelation, dogma, or holy texts. There's intuition, or trusting your gut. If you're watching Thunk, you probably trust the claims of science and scientists a great deal, even knowing that the romanticized ideal of science conflicts with the mundane reality of spending years staring at columns of data in Excel while worrying about funding. But in some debates where somebody is disagreeing with scientific consensus, whether they're anti-vaxxers or creationists or climate change deniers, I've heard some proponents of science assert that it's 100% objective, that unlike other methods of accessing truth, it's a perfect abstraction of logic and evidence that's totally free of any bias or subjectivity. Well, not really. Most implementations of the modern scientific method make a number of important assumptions that are, on some level, arbitrary. Whether or not they're as arbitrary as assuming that your gut is never wrong is up for debate. But they are still assumptions, and they are still arbitrary, and knowing what they are is an important part of understanding science and its operation. For example, in order to do science, one has to make an implicit assumption of naturalism. That is to say that all phenomena are caused by natural causes, not supernatural ones. This is why papers entitled Thermal Fluctuation in Transport and Type II Superconductors, or Maybe Fairies Are Playing with Our Gauges, don't get published. That assumption isn't logically bulletproof, but it is necessitated by science's requirement of experimental repeatability. If the data that you're collecting today is subject to the whims of some supernatural entity, which you can't measure or control for, who's to say they won't be totally different tomorrow? That's not to say that someone can't be a good scientist and still believe in the supernatural outside of the lab. It's just that when they're doing science, they generally must make the assumption of purely natural causes. There's also a general assumption of the universal homogeneity of physical laws, that the rules which govern the things in your experiment are just as applicable outside the lab, that they're relatively unchanged by time or space. I mean, science would be pretty unremarkable if all it did was tell you things that happened in labs. And that's not just because a full day of pipetting is really boring. There's another assumption that science makes which isn't really intuitively obvious just because we take it for granted so often in our lives. Induction. Induction is the process of recognizing patterns and then generalizing those patterns into rules, and it's generally considered to be a foundational component of scientific research. It's also a problem, so much so that there is a capitalized problem of induction. Let's say that you have 2 billiard balls on a pool table. You roll the first one into the second one 100 times, and each time the first one stops and the second one starts moving. You'd probably say that the first ball's motion starts the second ball rolling, and that other billiard balls will behave in the same fashion. You might even write an equation to describe how the second ball will move. The capital P problem, most notably raised by David Hume, is that sequence of events. There's no concrete reason to expect it to repeat. You've probably heard that correlation doesn't imply causation, but unfortunately, nothing necessitates it. We can't see causation. It isn't some substance that we can interact with. We can only see one event followed by another event and hope that they keep on happening in that sequence in the future. Maybe on the 101st trial, the first ball reverses direction or vanishes altogether. There's no guarantee that those things won't happen. We're just guessing that they won't. And unfortunately, we can't say that induction just happens to be right a lot of the time and justify it that way, because that's using induction to justify induction. That's a problem, at least for philosophers, and especially for philosophers of science. Without a concrete justification for induction, all of the capital T truths that we think we know due to science are really just hypotheses waiting to get knocked over by one contrary observation. And that's kind of the reality of the situation. When CERN announced the existence of the Higgs boson, some people celebrated the discovery as though somebody at CERN had grabbed one with a pair of really good tweezers and held it under a microscope. But in reality, in order to establish the existence of the Higgs, CERN had to use some very sensitive equipment, and in the paper announcing the discovery, there was a value, the same value that's in many modern scientific papers, which stated the odds that the data that they hoped represented the Higgs was just a fluke. I mean, this is one of the most significant discoveries in physics to date, and it's got this asterisk attached to it that says there's still a 1 in 3.5 million chance that if there were no Higgs, we'd still have gotten these results. It's not a certainty, it's still just a guess. So, science makes a number of arbitrary assumptions, not unlike other methods for accessing truth. And because of the problem of induction, we can't even be sure that the things that we supposedly know due to science are actually true. They're just more probable than not. Why is it so popular? Well, because it's remarkably successful. Despite the fact that science isn't some perfect objective entity abstract from human thought, despite the fact that scientists aren't any less prone to bias than anybody else, despite the fact that scientific discoveries are just statistical likelihoods, not necessarily true, science is still way better than any contender at making very accurate, very specific, and very risky predictions. Out of all of the methods which people use to access truth, science isn't different because it's perfectly objective or free from assumptions. There's just as many assumptions in science as anything else. But those arbitrary assumptions still seem to be the best ones that we have for saying there will be an eclipse at this time, or if you smash these particles together at this speed, then you'll see an energy spike at this frequency, and that's the Higgs boson. Probably. Whether that's because they're more accurate than other assumptions about the universe, or because they're just better suited for making accurate predictions, that's a different question. Whether someone wants to accept those assumptions as actually true, or just necessary for getting stuff like medicine and computers, that's their call. But I've at least got to respect the fact that out of all of the methods of accessing truth available to me, only scientists can even venture a guess at how many inches of snow I'm going to have to shovel off of my driveway. Do you think that the assumptions inherent to science are true or just necessary? Do you live on Long Island and want to lend me a snowblower? Please leave a comment and let me know what you think. Thank you very much for watching. Don't forget to blah blah subscribe blah share.
Slime
And
or
don't stop
gag. You're going to need some borax. Borax is a detergent that can be found in the clothes washing detergent aisle at most grocery stores. A sealable container that you are going to use to make a saturated solution of borax. A container that you're going to mix all the ingredients in. Make sure that the container is something that you wouldn't mind destroying if you don't clean it out right away. Some water. I used 2 cups just in case I needed to mix something or I needed some more water. A container of white glue. Make sure the glue is the non-washable kind because the washable kind is not going to work. And some food coloring. Did you know they make neon food coloring now? Pretty cool. So the more colorful you want your slime, the more food coloring you're going to need. You may want to use gloves when you make your slime because the dye will get caught up in the polymers of the slime once it starts to polymerize, but before that, it can dye your hands. Make your borax solution. It doesn't really matter how much you use, you just want to have it be saturated. This means that no more is going to dissolve in the container. Add water and seal the container. And shake the container. This will saturate the water with the borax, which is what you want. Run hot water to clean out the pipes from any borax you may have spilled. Notice that there's solids at the bottom of the borax solution. This is what we want. We want it to be saturated to the point that no more is going to dissolve. Squeeze out as much of the glue as you can. The volume of the slime will be about twice the amount of glue that you use. I seal the glue back up because, well, I'm a teacher and I figure I can get this glue to do something else somewhere else. Add about the same volume of water as glue that you used and start mixing it. It's more enjoyable if you do it with your hands. Grab a towel that you don't mind getting destroyed. Paper towels will work too. You can see on your fingers that you've thinned out the polymers of the glue, which is good because otherwise you would just make a solid chunk of glue when you added the borax solution. Use as much coloring as you want. I have found that about 30 drops per small bottle of glue gives a very good solid color. And then mix it again. Mix the mixture thoroughly. Look at the borax solution. You can see that the water is saturated with the detergent. Pour a small amount into the glue mixture. The borax is going to instantly start to make slime as it causes the polymers of the glue to form longer chains. Mix it thoroughly. It's gross, disgusting, and fun. When the slime starts to clump together well enough that you can break little pieces off of it, you're reaching the point where you need to add some more water until you get the slime consistency you want. Get your hands in there. That's right. Mix it. Mix it like you mean it. The more you mix it, the more water will come out of the slime and the more firm it will become. If your slime gets too hard, add a little bit more water. Do not leave your slime out on any fabric that you think that it could die, like your parents' couch, some carpet, etc. Always put it back in a sealable container when you're done with it. You can store your slime in a plastic sealable bag indefinitely, as long as the slime doesn't get too dried out. If it gets a little bit dried out, you can add a little bit of water to it to revitalize it. If your slime is sticky, add just a little tiny bit more borax or roll it around in your hands until more water comes out. But if it gets so dry that powder starts to come off it, your slime's done and you'll never get it back again.